Hello friends, my name is Harish Prajapati. I am studying in JNKVV College of Agriculture, Rewa, MP. I am delivering a presentation on seed storage under the guidance of Professor RP Joshi, Senior Scientist, Plant Breeding and Genetics. So let's begin. Basically, seeds are of two types. Based on their storability, they are divided. First, that is orthodox seed, and second is recalcitrant seed. Orthodox seeds, it can be dried up to a moisture content of 5% without lowering their viability. In fact, reduced seed moisture is positively correlated with storage life. Such seeds can be stored for longer period of time according to seed moisture present in it. Examples of such seeds with longest storage period is cereals, moderate for legumes, and low for grasses and vegetable seeds. They are desiccation sensitive. Second is recalcitrant seed. Seeds of this group are desiccation sensitive, so its viability drops drastically if their moisture content is reduced below 12 to 30%. Examples of many forest and fruit trees and several tropical crops like citrus, cocoa, coffee, oil palm, mango, caronda, jackfruit, etc. They are short-lived and survive for few weeks to few months, even with normal moisture content. Therefore, germplasm of such species is conserved in plant or field gene banks or in shoot tip gene banks. Seed storage. Orthodox seed can be dried without damage to low moisture content, usually much lower than those they would normally achieve in nature. Their longevity increases with reductions in soil, both moisture content and temperature over a wide range of storage environments. What is seed storage? Preservation of seed with initial quality until it is needed for planting. Stage, Stages of seed storage. The seeds are considered to be in storage from the moment they reach physiological maturity until they germinate or until they thrown away because they are dead or otherwise worthless. The entire storage period can be conveniently divided into following stages: storage on plants physiological maturity until harvest, harvest until processed and storage in warehouse, in storage in warehouses, in transit, railway wagons, trucks, carts, railway sets, etc. In retail stores or on the user's farm. Stages of seed storage: first, harvest; second, until process; third, storage in warehouse; fourth, in transit; and fifth, in retail stores. About seed storage. The ability of seed to tolerate moisture loss allows the seed to maintain the viability in dry state. Storage starts in the mother plant itself when it attains physiological maturity. Introduction of high-yielding varieties and hybrids and modernization of agriculture necessitated the development of storage techniques to preserve the seeds. The practice of storing the seeds starts from the ancient date itself, following simple and cheap techniques. Example: placing the seeds in salt, and the second is red earth treatment into red gram. About 1 kg of red gram is mixed with 1 kg of red earth, that is 1 to 1 ratio, and then the seeds are subjected to sun drying. After 1 or 2 days of drying, the grains are stored as such for seed purpose. Storage categories: orthodox seed water can be removed safely. 90 more than 90% seeds are orthodox. Intermediate seed, some water can be removed. Recalcitrant seed, water removal is lethal. Tropical fruits seeds can be tend to be recalcitrant. Objective of seed storage: to maintain initial seed quality, that is germination, physical purity, vigor, etc., all along with the storage period by providing suitable or even better conditions. Since the main objective of seed storage maintenance of an acceptable capacity for germination and emergence, it can only be accomplished by reducing the rate of deterioration to the degree required to maintain an acceptable level of quality for the desired period. Purpose of seed storage. Seed storage is the maintenance of high seed germination and vigor from the harvest until planting. Important to get adequate plant stands in addition to healthy and vigorous plants. The purpose of seed storage is to maintain the seed in good physical and physiological conditions from the time they are harvested until the time they are planted. Two unsold seeds are carried over in storage for marketing during the second planting season after harvest. Seed suppliers are not always able to market all the seed they produce during the following planting season. Foundation seed units and others have found this to be an economical, efficient procedure for seed of varieties for which there are limited demand. Some kinds of seed are stored for extended periods to improve the percentage and rapidity of germination by providing enough time for a natural release from dormancy. In the broadest sense, the storage period for seed begins with attainment of physiological maturity and ends with resumption of active growth of the embryonic axis, that is germination. Seeds are considered to be physiological and morphologically immature when they reach maximum dry weight. Seeds are considered to be physiological and morphologically immature when they reach maximum dry weight. The second segment of the storage period extends from the harvest to the beginning of conditioning. The third segment of the storage period begins with onset of conditioning and ends with packaging. The fourth segment of the storage period is the packaged seed phase, which has already been mentioned. The packaged seed segment is followed by storage during distribution and marketing, and finally by storage on the farm before during planting. The control that a seedsman has over the various segments of the storage period for seeds varies from a high degree of control from harvest to distribution to much less control during the post-maturation, pre-harvest, distribution, marketing, and on-farm segments. Despite variable degrees of control over the various segments of the storage period, the seedsman plans for storage must take into consideration all the segments. There are things that can be done, must be done if the quality of the seed is to be maintained. Principles of seed storage. The principal natural environment and when stored at ambient room conditions, seeds respond to constantly changing relative humidity and temperature. Maintaining seeds under controlled conditions lower metabolic activity, thereby reducing the aging process and increasing longevity of the seed lot. For most seed, a cool and dry environment is preferred, and for orthodox seed, the cooler and drier, the greater the longevity that can be achieved. Harrington's rule states that each 1% reduction in moisture content doubles the life of the seed. Each 10 degree Fahrenheit in temperature doubles the life of the seed. Why we need factor influencing the storage? Fully ripened seeds will retain viability longer than seed collected when immature. Seeds of high initial viability will store better than those with the initial viability. Seeds with hard impermeable seed coat will retain viability longer than those with soft impermeable seed coat. Undamaged seed will remain viability better in storage than seed physically damaged during collection of processing. Lower than moisture content, that is 32%, and lower the temperature, that is 40% degrees Celsius, longer will be the period of viability. The safe moisture content for sealed storage is 4 to 8%. Effect of temperature. Temperature is important, influences the amount of moisture and also enhances the rate of deterioration reactions occurring in seeds. High temperature has changed the rate of biochemical processes, triggering more rapid deterioration that resulted in rapid losses. On the basis of their dormancy occurring in seeds. Dormancy, there is one term, that is dormancy. It is the dormancy is the state of rest period of a seed in which it does not germinate, or it is a state of inhibited growth of seed as result of internal causes, but the seed remain viable for a period. Limitation. The same practice are not hold good for present day agriculture because large quantity to be stored, exchange of varieties and species, and exchange of genes. Thank you.